Hello guys, welcome back to the channel. In this second video we take a look at the basic 32 amp hour battery box that I put together and take it a stage further by adding a number of DC input and output options, as well as swapping out the BMS for a higher amperage separate port BMS. This change in the BMS was brought about by the need to be able to charge the battery in whatever state it's in. With a common port BMS, the charger can be disconnected from the battery if the BMS detects an over or an undervolt condition. This can be potentially damaging to solar charge controllers and is really not a good idea. The separate charging port prevents this occurring. We start by removing the battery tray from the box enclosure. Right folks, this is the battery management board that I've currently got installed on the battery pack, but this is going to be coming off and replaced by a separate port battery management solution, so I can charge it without fear of it being disconnected. So what you've got here is a 35 amp BMS. Just see if you can see that there. Yeah, that bit there, 35 amp, just there. Yep. The blue lead there is going to be and the black lead there is going to be the minus output, which everything connects to up here on the terminal. And then up here you've got the battery plus leading out to the positive terminal there. This is just a standard piece of nylon kitchen board that I've put as alternative use. I don't know whether you can see here, but this is a piece of basically PCB board material without any tracks on it. It's just the raw board. I bought a sheet of it once, and I've used this to provide a barrier between the battery management board and the battery pack itself, which is behind here, and that's just hot glued onto the spacers there. So that's just a bit there, and then the battery management system is hot glued itself onto that piece of PCB material, and then obviously I've just got some Kapton on tape to keep the cables tidy there and just to keep things nice and sweet. So what I've got to do is basically strip this BMS off and then replace it with a separate port BMS. I'm actually going to be fitting a 45 amp BMS just to allow me to drive it and get a bit more capacity out of the pack. Well, sorry, no, not capacity, but higher current draw, because obviously I may have a number of 30 amp connections coming off the fuse board, and if I've got a 35 amp BMS, then that's going to restrict that to 35 amps continuous, even though this pack will allow me to draw 200. So that's just a few thoughts on that. I didn't want to go too high, because obviously if I do draw currents approaching 200 amps, then my run time is going to be reduced significantly. But that's the basic fundamentals of it. I don't know whether you can see, there's actually another piece of that silicon board on the bottom side of the pack, just giving a bit of protection to the terminals that are inside there. So yeah, that's the battery pack. Yeah, so this is just showing you the other side of the battery pack. You can see here the other end of the kitchen board, and the actual grip is going to provide a nice way of routing cables from the DC outlets, which are essentially going to sit here, because this is the sort of like the end of the ammo can, and this gap, or this space, void for want of a better word, that's going to be filled up with the DC outlets and the wiring, which is going to come up through here to the fuse board. So that's it really. Okay, that's the first hole drilled. Quite tricky, as this material is really strong, and sorry, really soft, and you need to take your time when you're using a one of those multi bits, because you know, you can very easily let it rip and just chew through the material, and if you're not centered properly, then you're going to ruin the container. So just be warned. Right guys, 4 holes. I think that's about as close as I can get them to be in alignment, with no jig or anything like that. Just basically a pilot hole to start off with, and then using the multi-bit a step at a time, just checking using the guide that I've got here. It's not bad, is it? If I just drop this one in, you can see that's not a bad fit at all. So I'm quite happy with that, considering the mess I could have made of it. Yeah, I'll settle for that. Top marks. Hi gang, right, bit of an update. So earlier I installed the sockets under here in this area, and what I'm doing now, or what I've finished doing now, is I've just finished preparing the wiring runs to go from the sockets here to the fuse board here. I've disconnected the actual battery outputs and taken the lid off, so that helps me you know, with safety and whatnot. So just to run you through, these two 16 gauge wires are for the 12 volt DC cigarette type socket and the USB socket, and they're going to be going onto a 10 amp fuse, and these two bad boys are 12 AWG, and they are supplying the power pole socket just here, which is going to be fed from these two 30 amp fuses here. Yeah, that's right, 30 amp. So what remains to be done now is, obviously I've noticed that this thing has actually come loose from the hot glue as well, so I'm going to have to put a screw through there. What's left to do now is actually swap the BMS and to rig up the charging port for the BMS. The problem being at the minute is I'm maybe a little short on the 12 AWG wire. I want to use 12 AWG and not the 16, because even though the maximum charge rate with the charge controller and the BMS is 10 amps, I want to minimize the voltage drop on the wires due to resistance. So obviously a thicker wire is a less resistance. So so that's where we are. Oh, so less resistance and less heating as well. Obviously, if we are charging at 10 amps, then a thinner wire is going to get warmer than a thicker wire. So that's where we are with that. I've practically got as far as I can for now without having to change the BMS. So I'm just going to pull the battery back out. Obviously, I need to secure this bit and then tidy the wiring up. So that's where we are. It's taken a few hours, but we're getting there now. And the second stage of the build is nearing completion. Right then, this is one of the PowerWorks power pole panel mounts. What is it to say about these things? Well, apart from being very, very functional, they're also very, very expensive for what they are. Considering that this is essentially just a plastic moulding with two pairs of power pole connectors inside it, a bit of a rubber dust cover. That's what you get. They're very expensive. I guess because fools like me buy them. But anyway, that's not the point of this particular video. So you can see in there that this particular panel adapter's got yellow and black connectors rather than the standard red and black connectors. So what I wanted to do is, this is actually the one I'm going to be using for the solar charge input, or the charge input, however we charge it. And the reason why I wanted to put a yellow one in there as opposed to a red one is just to differentiate and give somebody that's perhaps not familiar with my setup a visual clue that it's not an output. So that's why I'm using the yellow and black. I've also got yellow and black on my solar system as well, just to tie it all together. And the way that you actually split this out, it took me about 10 minutes to figure out how they actually come out. But if you look on the top there, if you can just see it, in that little hole, there's a roll pin, and that goes all the way through to the other side. And what that does is it actually passes through the holes. I'll just grab this one here so you can see. This is the solar charge cable that I made up. It actually passes through that little hole there. Let me get it in focus. Yeah, see that hole? It passes through there, and it stops the actual plastic connectors from moving in and out like that, I guess, and keeps them in place. And the pin goes through both the connectors. So once you've got that out, you need a suitably sized punch and a hammer to do that. Once you've got that, the connectors fall out, and you can replace them and put the roll pin back in and just drift it down so that it's clear of the threads on each side. I didn't get that in shot yet. And the other thing is, there's quite a bit of daylight around. I don't know whether you can see this. No, let's put it down there. Just underneath the connectors, there's quite a bit of daylight, so it's not a weatherproof panel socket by any stretch of the imagination. I mean, if you wanted to weatherproof it, you'd probably have to run some silicone down there once you've got all the wires in, etc. Pump some silicone in there and let the silicone go off before you fit it. But yeah, yeah, these things retail at about $24, so like I say, quite pricey for what they are, but I guess they do the job. And obviously I use power pole connectors in all my stuff, so I wanted something compatible. So that's just a little bit of a warning for anybody that's considering building one of these. Okay, I'll speak to you soon. Okay, next engineering challenge. I wanted to give the charging port a common wire back. So what I've got here is a 12 gauge and a 16 gauge wire tacked together there and there, and that's, come on, focus. That's gonna, this thing will actually focus. Yeah, that's basically going to go in the socket. You'll see what I mean in a minute. Okay, you can see there, that's the intended fitment. Quite a tight fit to get those wires in there, but it does fit. The insulation being silicone, it's quite squishy, so you can squish it down a bit, and it does go in there, and the terminals are fully forward. And that's the completed charge socket. Right folks, hope you can see that. So that's the existing 35 amp BMS, which is a common port for charging, because it's only got the two wires coming out the top, and we're going to replace it with that, which is a 45 amp BMS with a separate charge port, so that I can charge it whilst it's in use using the solar system. So the first thing I've got to do is basically strip this plate off and undo those terminals. So it's going to get a little bit interesting, because I've got to make sure that obviously that thing and that thing don't touch. Okay, I'll see you in a bit. Okay, now you can see how the pack is actually held together. So basically I've snipped these two tie wraps, which has allowed the top plate just to fall away a little bit. Now what I'm going to do is I'm going to undo the negative first and pop one of those over the end and tape it up so that it doesn't come into contact with that one. Okay, I've removed the balance leads. That effectively turns off the BMS, but what I'm also going to do is I'm going to disconnect this one first, which will completely make this dead and safe. Once I've done that, I can just try and get that off there. So that's the next step. I've actually just cut away this Kapton tape slightly so I can get access to this here. Right, so BMS lead is off, that's off. So for all intents and purposes this is now inert, and what I'm going to do is I'm going to use this soldering tool to try and prise away the BMS from this bit of PCB material here. Okay, first go. It's probably gonna, there you go, it's off. That was painless. So I've just got to remove it now, and then we'll put some terminals on the new one. Alright, so we've got, that's the old BMS. It's not very old to be honest, but I wanted one with the additional charging port. From two different suppliers, but I suspect these are out of the same factory, because from a manufacturing point of view they are exactly the same. Excuse me. And the other thing is, they're not too dear either. Will Prowse, give a shout out to him. He's been advertising these on his YouTube channel. He's been having some success with them. In particular, this brand, the Daily or Dally brand. He's now got them listed on his YouTube channel, and even on his kits for purchase. So if it's good enough for him, it's good enough for me. Right, first engineering challenge. This wire is 10 gauge. These crimps are 12 gauge. So I have to take off the plastic sleeve and open up the ferrule inside, so allow me to get the wire on. And then what I'm going to do is, just to give it some insulation, I'm going to whack 2 layers of heat shrink over there. Right folks, so I've got the terminals on the BMS now. The problem I've got now is obviously I've got to get that charge wire connected somehow to outside the box, no, the other side of this plate. So what I'm thinking, I'll just stick that bolt about there. That's going to give me a nice little 6mm binding post onto which I can attach the lead coming from the solar charge input. That's the theory anyway. And I can bind the positive onto there. So we'll have two separate negatives. One for the battery through the BMS, and one for the charging. So the load will connect across there, and the charge will connect across there. That's the theory anyway. Okay, here's another shot of the bottom of the pack, showing the PCB board I've just put there to give an insulation barrier between the terminals, which are inside there. Obviously, on the top side, you've got this board, and there's no exposed terminals on the side here, so we're all right on the sides. And when it's in the box as well, I've got a piece of foam just packing out the void between the sides of the battery and the inside of the box. So next job is to glue the BMS down. Okay. Right, so I fixed the relay down, but the problem was the screw was poking through, so I've just covered it up with a bit of heat shrink. How's that? Right, so the BMS is glued in place, and I've connected the negative lead to the battery. Just to be careful, I've just insulated these ends so it doesn't hit that. And I haven't plugged this in yet, so the BMS isn't live until I plug this in. So next step is to put this back on with some tie wraps, and then we can start reattaching all the wires. Alright, before I actually put it back together, I thought it might be an idea to check the balance state of all the cells. So I've just measured the voltages across the pins there on the balance plug, and each of the cells is 3.3 something. So as long as they're within 0.1 of a volt, that's quite nominal. They're all about 3.78, 3.79, sorry, 3.37, 3.39. So a hundredth of a volt is nothing. So, or a couple of hundredths of a volt is neither here nor there. So pack's still in a really good state of balance, and I'm quite happy with the job that the old controller's been doing to keeping them in that state. Okay, one of the last things to go on is this thing. This is the temperature sensor, and I'm just going to tape that just there like that, so that it records the temperature of the batteries. And this is displayed on the shunt display in real time once the shunt is energized. And another bit of tape just keeps the cable tidy, so that you can see the sensor there. Tie wraps fitted. Just need to put some more tape over there just to stop that wandering. Right, we're about ready for wiring. Okay, it's all powered up. Got a voltage across there. I've got a voltage across there. Yeah, the battery ports, sorry, the balance ports plugged in as well. Good to go. Right, it's all ready for going in the box. Right, one last look inside. Before we drop that in. Okay folks, so the battery's in the box and all the feeds are in place now, and I've got the battery charging port rigged up, and I'm reading 13.5 volts, which is the same voltage as I've got here as to what's on the charging port down there. So now we're ready for putting the lid back on and then completing the wiring of everything up. Yeah, it took me a while to get to this point, but we'll see how we go. Moment of truth, guys. It's all powered up and switched on. You can see the little light in there is on. Display's on. The switch is engaged. So now I'm just going to run around and test a few voltages. Make sure all my outputs are alive. And then that should be it. Right, just a quick spin round. You've seen it before. If you've not seen it like this, there's a bit of a discrepancy in the voltage there. But that is half a volt, sorry, a tenth of a volt lower than what's being displayed on the shunt meter, and also my voltmeter. So I'm not bothered about that too much. Oh, there we go. It's just wavering on there. So there's probably half a volt difference there. So I'm just going to check the voltages across here now and see where we go. Right, so I've got my cigarette lighter plugged into that, and that's not bad at all. Okay, you power poles straight in to the voltmeter, well, the wattmeter. 13.47 on that one. .47 on that one. And we're showing 13.51 up there, so not far out. And lastly, can't video this because I'm using the phone. Let's see if it'll bleep on me. Not while I'm recording. Oh well. There you go. Okay, I've got the phone plugged in. Let's see if I can just grab this shot, and you'll see charging my Galaxy S5. I'm pulling about 340 milliamps. Okay folks, if you made it this far, you'll have seen how relatively straightforward the build has been. It all began when I saw a batch of used cells advertised on eBay and progressed through the testing and assembly stages to deliver a completed product, which is something that I'll be able to use for quite some time. The modularity of the design means I can make repairs as and when required. I could even increase capacity by using the slightly larger 10 or 12 amp hour cells should the need arise. I've already used the battery box in my latest PO4 park activation, and it did just what it said on the tin, running 2 radio transceivers concurrently. Anyway, if you're at all inspired by what you've seen here, please consider dropping me a like or subscribing to the channel, and I hope it inspires someone else to go out and build their own battery solution, just as I did after watching Julian White, OH8STN, and his excellent series of videos. In the meantime, take care, and I'll see you on the next video. 7-3.